The center of gravity method is based on the concept of coordinates. Coordinates on a flat plane. That's how you can tell that this particular question is a center of gravity problem, because that's exactly what it's discussing. Art contractors must locate equipment at a staging area to serve 3 construction sites located at these coordinates. This is center of gravity. All right, and then here are the coordinates, 0, 2, 0, 4, and 5, 5. Traffic between the staging area and each of the 3 sites will be equal. What is the best set of coordinates for the equipment staging area? Right, the key to center of gravity is that it calculates a new set of coordinates, proposing a location among the other sets of coordinates that you gave the technique. Now, this particular problem is the easiest case of center of gravity, because when you have a set of locations and it says that the traffic or the amount shipped is going to be equal to all of these locations, the only thing you have to do is average the coordinates that you were given. That's it. Now, with this particular problem, the way that it's written, one thing that would be helpful would be to just organize it a little bit more. This is exactly the information right here that we need. They refer to an X and a Y coordinate on a grid. I'm going to organize this. The first location is at 0, 2. The second location is at 0, 4. And the third location is at 5, 5. The reason that I'm doing this is just to make it easier to average them, because the new staging area should be at X coordinate, I would say 0 plus 5 divided by 3. I'm just averaging, which is like 1.6667, going to round to 1.7. The Y coordinate for the absolute perfect location for the staging area, technically, is 2 plus 4 plus 5 divided by 3. That's like 3 2/3, 3.667, which for convenience I will round to 3.7. But these are just the averages of these 2 columns. That is the answer to the question right there. That is where the staging area should be located. Oh, now if you look at the next question, the next question is referring to the same coordinates. Oh, okay. In fact, the same company. They must locate their staging area. These are the coordinates. Now, wait, what's different about this question? What makes it a different question? Traffic between the staging area and each of the 3 sites is 30 trips a week, except for the site located at 5, 5, which is only 10 trips. But then it's asking the same question: what is the best set of coordinates for the equipment staging area? Oh, this particular case of center of gravity is almost as easy as the first case. We just have to remember that if traffic varies between the locations, and that was the new sentence that was put in there, this idea that it's 30 trips from here, from this location and that location, but it's only 10 trips between the staging area and this particular location. If there is some variation, we just need to calculate the weighted average of the coordinates. Now, for this problem, just to stay organized, I'm going to copy the coordinates over again. Okay, 0, 2, that's that one. 0, 4, that's that one. And then 5, 5. Down on this part of the note frame, I have a little bit more room. I'm going to make another column, trips. Each of the 3 sites, 30 trips a week, except for, that's what I'm sort of focusing on, 5, 5. Okay, that's this location, is only 10 trips a week. So I'm going to note that 10. The other 2 would then be 30. Now I calculate the weighted average. Now, how do you calculate the weighted average? The formula is your perfect X coordinate is the sum of each individual X coordinate multiplied by Q, the quantity, the traffic, the amount that's shipped. Wait, that's just the numerator. In the denominator, you add up Q, the amount shipped. You say, now wait a minute, wait, where it's amounts here, in this problem, that's exactly what trips is. Trips is the queue. It's just some measure of the traffic between the two. The y-coordinate, very similar template. In the numerator, what you want to do is multiply each y-coordinate times the traffic to that site, add them up, and divide by the overall amount of traffic. Oh, all right, so to get started on this, one of the most convenient things that you can do is actually notice that the denominator is the same in each case. That's just the sum of the traffic. It's really easy to do here on our table. That's just adding this up. Okay, 30 plus 30 plus 10 is 70, 70 trips. Each one of these ratios should have a 70 in the denominator. Okay, well then I just need to do the scratch work for the numerator. In the case of x, I'll work over here. I say 0 times 30 plus 0 times 30 plus 5 times 10. All of that has to be divided by 70. What was I doing? I was pairing up the x-coordinate with the amount, the x-coordinate with the amount, the x-coordinate with the amount. Okay, I added all that up in there. Well, that's 0, that's 0. So this turns out to be 50. So the absolute perfect x-coordinate for our staging area turns out to be 50 divided by 70, which a little bit of rounding, how about calling that 0.71? That's the x-coordinate. Now we need to do some more scratch work for the y-coordinate. Let's see, where can I work? I'll work down here. For the y-coordinate, I'll say, wait a minute, I have to be careful. The y-coordinate 2 times the amount shipped, 30, plus the y-coordinate 4 times the amount shipped, 30, plus the y-coordinate 5 times the amount shipped, 10. That's all in the numerator. That's all divided by 70. All right, well, I added all that up on my calculator. You can check me on this. I got 230. So the perfect y-coordinate is 230 divided by 70, or 3.29. Right, remember that the actual answer is just the coordinates, the proposed location. That would be the 0.71. Perfect y-coordinate, 3.29, or 230 divided by 70. That's the answer to this particular question.